So I'm Jim Blakely from Intel. I've been in the cloud space for the last 7-8 years, since well before it was called cloud. I've been working with a lot of the cloud service providers. I want to talk to you a little bit today about what's been happening in cloud we now see going over into the video delivery space and how it's really transitioning the way people do these sorts of media processing solutions at scale. And then I'll turn it over as quickly as I can to Eric Weinstein from iStreamPlanet. I'll talk to you about what they're doing in the space and how they're leveraging some of these very, very large-scale, standard high-volume solutions in order to support software-based video delivery. So let me frame this a little bit. From an Intel perspective, we look at the overall digital services economy, which is this endless spiral of new devices, new services, and corresponding build-out of the cloud. Now, this is a general trend in the industry. It's been happening for quite a while now. But video is becoming a greater and greater portion of the content that's streaming over the internet today. Or that's moving over the internet. In fact, in prime time in the US today, many of you have probably seen the statistics or other very similar ones. It's something like 79% of the traffic on the overall internet in prime time in the US is video traffic. And so that creates a significant challenge for the infrastructure to be able to support that. So how does that play out? From a cloud economics perspective, if you look at sort of where a large cloud service provider spends their money from an infrastructure perspective, a good chunk of that is on servers. These are, fortunately for Intel, most of these are Intel-based, Xeon processor-based servers. However, they drive the cost structure within the data center. Not only do they drive the cost structure from an equipment perspective, but they also drive the cost structure from a power consumption and distribution and cooling perspective. So anything that can be done in order to increase the efficiency of these data center environments, to reduce that overall, first of all, the equipment that's required in order to support it, as well as the cooling and power that it takes to do that is really key. And so a lot of what we focus on from an Intel perspective is how do you drive better total cost of ownership into these cloud-based infrastructures? And that means, on one hand, Moore's Law, which we've been driving relentlessly for the last 50 years, has really paid off mostly here. But the other thing that's happening is a transition in many of these environments from custom-built hardware, specialized hardware, to what the industry calls commodity hardware. We prefer to think of it as standard high-volume hardware, which is the standard equipment that you get from your key partners like an HP or a Dell or now Lenovo, who build standard servers that you can buy pretty much anywhere. Those have an incredibly good cost structure. They're the ones where the design point for the industry, for the clouds, is clearly built around sort of a standard 2-socket Xeon server. So what we find is, generally speaking, industries take off when you can drive what's done in those industries to something that's built on a standard high-volume server, mainly software. So you'll hear from Intel over the next, for the last 12 months and going forward, a great focus on what we refer to as software-defined infrastructure. So obviously compute these days is very much a standard sort of environment, but networking, storage, and particularly media processing has remained in many cases, in many solutions, custom-built hardware. From a networking perspective, you see moves to SDN, software-defined networking, and network function virtualization to drive standard commodity equipment into networking. And we're going to talk a little bit today about driving those same sorts of economics into media processing, where the media has classically been driven as part of a closed solution made up of DSPs, ASICs, specialized equipment that has to be deployed once, and then once it's deployed, it's single function and stays that way forever. We're driving continued improvements in both the core processing technology to make it so that you can do more and more of the processing on standard server-based hardwares. They're still at a point now, particularly for newer sorts of encode and decode algorithms, where fixed function hardware is required, so we have acceleration technologies built into the platforms to be able to support video processing specifically. And so that is a mechanism that we're using to help move this industry to much more of a standard high-volume solution. So with that, I did get through that pretty quickly. I want to turn it over to Eric, who's going to tell you about one of the solutions that his company is driving and how it really fits into this sort of process of transitioning the industry towards software.
Where am I going from?
Just page down. There. Whoop, whoop.
Technology. Thanks, Jim. So I'm Eric Weinstein. I'm with iStreamPlanet. Just a quick summary on us. iStreamPlanet is focused on delivering solutions to drive live video processing. We've transitioned over the last couple of years from a services company to more of a software company. We've built a software platform that now lives in the cloud to handle media processing, everything from ingest to publish, transcoding, packaging, translating, everything in that sort of media processing pipeline. And we've built that in the cloud to sort of help scale out the industry. I mean, we've had some solutions in the past where we were all based on hardware encoders in our own data center. As the industry has grown, that has become sort of not really the scale solution we're looking for. So the company went on a mission a few years ago to build a software platform that can be completely open and reliable on any public cloud, private cloud, or as we'll go into some private data centers. So as we're looking at the landscape today, where you have 24/7 streaming for every channel that needs to be to every device. Is this the right slide? Yes, it is. Sorry, this is fine. We knew that there had to be a solution that was scalable to manage the ingest and all the pieces of the workflow. So let me jump ahead here. This is a little out. So we built what we call Aventus. And Aventus is what we call the first multi-screen 24/7 live video SaaS model. It does everything from ingest to DRM, encoding to multiple bit rates, multiple packaging, multiple output to multiple destinations. And it's the only cloud live service that can support 24/7 live linear streaming. And also it provides in-depth real-time telemetry across every part of the workflow. So we've built a very transparent platform to give content owners and publishers a view into every piece of that workflow that was completely scalable. And we built it on an API set, so it's completely controllable by anybody who's using it. But we also have a whole tool and fully managed services as well. You may have seen this, probably not seen it, but notice it was used in recent events like Sochi Olympics and the Super Bowl. We provide support for everything that NBC Sports does in our Live Extra app. That all runs through the Aventus platform. That slide was out of order. That was my fault. So when we talk about Aventus, Aventus sits what we call in the center of the live multi-screen workflow. When you have acquisition, ingest, and then you have delivery and playback on the other end, Aventus sits in the middle. It enables ingest, powers all the transcoding and packaging, and delivery to all the multiple devices, the layers on DRM, as well as manages closed captions, and also manages ad insertion as well. So every piece of this workflow that we've sort of learned about over the last few years, and as we're continuing to learn about as the industry expands and grows, we're continuing to iterate on the software with updates as requirements change from different partners. Because you'll find that as different, there aren't a lot of standards in this OTT workflow right now. We're sort of getting there. But as we get there and as we learn, honestly, you learn from different customers and different requirements, we're really just updating the software to manage those. So when operators and programmers and broadcasters and content owners are looking to go to OTT, and if you have a scale, a multiple channel operation, there are three really big challenges. Your scalability, the changes in the market, both from an operations point of view, but also from a technology point of view, and also monetization. So we built Aventus to solve all three of those. Scalability, so we can stand up multiple instances of the software in seconds in a workflow that in the past where you had to procure hardware and rack it and find a data center and people to manage it could take weeks. We scale up channels within seconds. So we're now at probably 45 seconds where we're scaling up to multiple instances of the software. So if you have a multiple channel operation and you have a number of channels that you're doing and you want to start off with a number of channels, we start there and then quickly you want to scale up to more, that takes honestly minutes. So that provides a lot of elasticity to the content owner and sort of doesn't have to then invest in so much hardware or any hardware at all necessarily to manage what they're doing. In the rapidly changing market, so we take the headache away from building this whole operation. We want to make it as smooth and simple as possible to maintain your sort of 24/7 live linear channel or your live events without having to invest in hardware and power and infrastructure to keep up with that technology. And on the monetization level, we built in support for different levels of multi-screen monetization between pay-per-view as well as managing ad insertions. So we also, our software will also manage tones from broadcasters to insert ads, as well as we have it all completely API based. So we have a number of customers that are using what we call a big red button solution to hit a button and insert ads when necessary, because a lot of these sort of grassroots events may not have the tones to manage that. So we sort of are flexible to manage different parts of the monetization model. But the bigger part about this is what we wanted to do was build software that had global reach. And we have our own private cloud in Las Vegas where we manage a number of channels, but we built a completely open architecture to be able to integrate into public clouds. So right now we are integrated into Google Cloud, CenturyLink Cloud, and Microsoft Azure Cloud. So what that does is that gives us a global footprint of our software around the world. I think with Google Cloud, we're probably now in 140 data centers in 30 countries. CenturyLink Cloud also gives us in-country ingest and media processing. And Microsoft Azure Cloud gives us a whole stack of other services, including VOD and CDN as well. So when our customers are coming to us and we have live channels that we need to ingest and process in the Far East or other parts of the world, in the past we would have to tunnel that via some sort of connectivity back to our Las Vegas cloud. Now we no longer have to do that. We have local cloud pops in different parts of the world, so that makes that ingest and processing a lot easier. And then the other piece of it, which also focuses mostly on what we're doing with Intel, is deploying Aventus on the HP Moonshot platform. So HP Moonshot is a chassis that supports upwards of 80 to 100 live channels in one single rack. So it's a completely dense solution, and that can go on-site in a customer's data center. So that's in their private cloud. So when we're talking to customers right now that are focused on initiatives for 2020, 2025, or their power and conservation initiatives that they need to be saving, this provides them a complete IP workflow in a much denser solution than they would probably do before. So just on some of the points here, Aventus on Moonshot handles more HD channels at a lower cost per channel compared to traditional blades. So we're talking, somewhere, as I said, 80 to 100, depending on the profile of each. You might have some 1080, some 720, but that's pretty much what we're working with now. And you can scale up quickly on this. Basically, it comes in a preset Moonshot with the software installed. You rack it, power it, and network it, and you're good to go. And then you always can use that extra capacity on that Moonshot for redundancy as well, so you have an always-up service for your customers. And then you're probably talking about, I think what our engineers have figured out is there's probably a 3 to 5 times reduction in power consumption on using the HP Moonshot. And then also the bigger part of that is a reduced data center footprint. So for these large customers that have hundreds of channels, they're looking to scale this up. They can do this in a fraction of the physical space that they used before. So that's pretty much where we are with Aventus right now. So we're supporting 24/7 live linear channels with this media processing from everywhere from ingest to publish, as I mentioned, and high volume live events where customers that have anywhere from tens to hundreds of live events that they're looking for a full scale solution. Aventus is set up to be completely self-managed, where if the customer can set up their own ingest, they can completely self-manage the platform via a web-based tool from any device. But we also have fully managed services as well. And that's, I did this one already. What's that? Yeah, actually, I'm sorry, I went over that last slide earlier, so I think I'm actually went through it all now.
Okay. So we do actually have, sorry.
Go ahead.
We have time for a few questions, if anybody has any questions. Yeah.
So are you aware of any ASIC-based transcoding server solution? If there is, what's the advantage of using Intel chip versus ASIC-based?
I don't have an answer.
Could you also repeat the question since we don't have a mic in the audience?
Is this mic? Is this one? That one's on. Okay. So there are a number of ASIC solutions that are out there from various vendors. I don't know whether you're asking about the system at the system level or you're asking at the individual chip level. There are a lot of ASICs out there today. They tend to be built into purpose-built historic appliance kinds of things. From vendors like Thomson, Ericsson, others who've built those kinds of solutions.
I'm more asking about this super high density.
Mm-hmm.
Let me say you can build hundreds of screens in very small form factor. Is there an ASIC-based?
Not that I've seen, and not in the sense that that has a sort of flexibility to be able to move this, change the software around. So, this, for example, in the Moonshot platform, it's one of a number of platforms. It's a normal CPU for all intents and purposes, and so if you want to run a standard application on it, you can run a standard application on it. If you want to run media transcode on it, you run it that way as well, which gives it, a far greater degree of flexibility than you can get from an ASIC or DSP-based system that's programmed to do one task. So it makes it much easier to get the kind of density. In the back, yeah.
Can you talk a little bit about beyond CPU capability in the cloud, so like GPU capability in the cloud, and whether that's here today or coming, and future iterations?
Sure. In 2000, and in fact, within the HP Moonshot system, there is a GPU, an Intel GPU, integrated into the Moonshot cartridge. Our latest Intel graphics capabilities, Iris Pro graphics, are in that system. So we have graphics in servers. They tend to be our E3 class server. The single socket servers have the E3 graphics within them. Their availability in public cloud right now is awaiting strong demand from the community. So if you want one, talk to your friendly cloud provider. I talk to them weekly. And so we're in great discussions for getting the Intel graphics capabilities into the tier 1 cloud service providers. So. Yeah, question.
Can you just talk about the ingest formats of bitrates?
I'm sorry, can you repeat that?
The ingest for the 24/7 channels. Can you say something about that?
So, yeah, so we support ingest via multiple number of formats. I mean, Aventus is completely IP-based, but we support satellite, fiber, and also over IP. So we will do conversion to IP if necessary, if we're requiring by satellite or fiber. But for 24/7, we can do either one of those, and anywhere from up to any format, any bit rate is fine. We've done 1080. We've done recent work on stuff that's 1080, 60 frames as well. So there really isn't an issue there that we've seen at all. So we've iStreamPlanet has built a network of connectivity partners around the globe to allow us to pick up feeds from anywhere, satellite or fiber. And as I said in the past, we would tunnel those back to Vegas. We don't have to do that anymore, but we still need to can work with a partner to acquire the feed. And also we'll set up ingest via RTMP, but also transport stream over IP as well.
We have time, probably one last question, if anybody has a question. Yeah, question.
Are there any scenarios where cloud encoding makes sense within a closed network deployment of streams, where content restrictions perhaps require that you deliver over a closed network for broadcast channels and that sort of thing, but maybe the encoding makes sense in the cloud?
So when you say broadcast over a closed network, meaning?
Meaning you're not, perhaps because of the content restrictions, you're not allowed to use a traditional CDN for the delivery to the last mile, but the encoding may make more sense scaling in the cloud. So using VPN to connect to the cloud, but then origin serving over your own managed network.
Right. Yeah. Well, I mean, we've seen. For us, we'll also had some questions about security for some events like that, or some content related to that. Our private cloud is in the SuperNAP, the Switch data center in Vegas, which is, I would say the most secure. That's what they told me it is. I believe them. When Homeland Security and Department of Defense are in there as well, take their word for it. And when the guys have guns, you take their word for it. So we haven't had any issue with that, but I think that's been brought up by a number of people that they have concerns about sort of getting their content out of their own data center and security there, but we haven't had any issue with that.
But do the cost benefits tend to still make sense with the cloud encoding when you include the data transmission and the private tunneling and things like that?
Right, well, yeah, that's something you definitely need to look at. I mean, we have, our connectivity partners that are connected into Switch, our private cloud, give us, pretty preferential connectivity on that. But I think that obviously that depends on the scale that you're looking at. I think that the broader you go up on that scale, the probably more cost savings you're gonna have.
Okay, I think we're out of time, but thank you very much for